Now, horizontally speaking, because we have a dilation factor of 1 on pi along uh, x axis, so there's a dilation in the horizontal direction too. So originally the period is 2 pi. Okay. Now we have a scale factor of 1 on pi, so the new period, okay, is the old period 2 pi times the dilation factor on, okay, sorry, okay, say the, the original period is 2 pi, the new period is 2 pi times the dilation factor. So let me just label it. Okay. Basically 2 pi times the dilation factor in x-axis, okay, and which is 2. So our period becomes 2. Okay. And the amplitude is 10 because the new amplitude is 10 times more. Originally it's 1, so 1 times 10 is 10. And now we can sketch our graph, okay, from the standard shape. Okay, in between from 0 to 2, there is the x intercepts. So the maximum is here, where x is in between 0 and 1 point. The value between the x intercepts, so 0.5, and we have 1.5 here. We should have minimum value. So our new sun graph would look like this. Okay, looks like that. So this is y equals to 10 sine pi x, and the domain is x. For one period is from 0 to 2, not 2 pi, because we have dilated it. Okay. Okay. Just okay. They are the dilation. Okay. Now let's show me. Sorry. Now let me show you how to do the final step of a transformation, which is translation. Okay. Okay, translation. We used the technique of translation before. Okay. I do an example here. If I want to transform the graph y equals to x squared to y equals to x plus 1 square plus 2. Okay, the process is translation, and the key point of translation is when you say plus sign or minus sign in a graph, this graph is translated from a standard graph. Okay, well, remember how did we find the turning point of a parabola? That's basically the process of translation. Okay, the original graph has a turning point at the origin there. Okay, y equals to x squared. Now we have a translation, so the shape doesn't change, the scale doesn't change, only the turning point is changed. Okay, so let's describe this translation first. Okay, first we have translate. Okay, translate it 2 units up. Also, this we call it the vertical translation, and we also have a translation, horizontal translation. The point is, in horizontal translation, you have to make whatever in the bracket equal to 0, For instance, x plus 1 equals to 0 and x equals to minus 1. So we translate 1 unit left. Okay, if it's positive, is right, but we have negative value is left. So the turning point will be minus 1 and 2 will be somewhere there. Okay, because we translated 1 unit to the left and 2 units up, and the new graph should looks like this. Okay, this is your new graph. Okay. Y equals to x plus 1 square plus 2. Okay, I do another example to show you what. Okay, I do an example in of the trigonometry graph to show you the physical meaning. Okay. So, okay, if I'm going to transform y equals to y equals to sine x to, okay, y equals to sine, okay, bracket x plus pi on 2, okay, and plus say, let's say plus 2. Okay, when we say plus signs, there are translations, so I have to, and well, there's also a plus sign inside the bracket, so it means there are two translations. So I just let me do the horizontal translation first. Translated 2 units up, 2 units up. Okay, because we have a positive 2 there. Okay, 2 units up. Okay, the horizontal translation should be translated. Okay, make whatever in the bracket there equal to 0. X plus pi on 2 is 0, so x is minus pi on 2. And translated pi on 2 units left. Okay, because there's a minus number. So just it's confusing just because like we used to find our turning point of a parabola, we have to make whatever in the bracket equal to 0 to find its horizontal movements. Same here. The horizontal translation movement is just make whatever in the bracket equals to 0. Okay, and we have minus 2, and it becomes translated pi on 2 units left. Now let me draw a graph. Okay. Here, this is your original graph. Okay, where the maximum is 1, the standard graph, and the minimum is minus 1. So we have basically 2 pi here, and 0. Here is pi on 2, and here is 3 pi on 2. Okay, so let's do the vertical translation first. So we move everything 2 units up. So your maximum becomes to 3. Okay, because we have 1 plus. So let's move it up first. Okay, first we move everything up. We move it 2 units up. Okay, up 2 units. So well, what happens your maximum, it becomes to 3, 1 plus 3, and your minimum is -1 plus 2, which is 1. Okay, now your minimum moved up to there, and in between your the values on your x-axis, your x-intercept move to the point 2, and here is 1. Okay, now we roughly can have a graph looks like this. Okay, okay, I just something like this. Now we have to translate it. Horizontal translation is pi on 2 units left, so we have to move the whole graph to the left by pi on 2 units. So this point here becomes to here. Okay, and just cross this out. And this point there moved to here. Okay, this pi on 2. So, and this point, the minimum point, moved pi on 2, which is on the x value is 3 pi on 2, moved pi on 2 unit to the left, which becomes at pi. Okay, and well, similarly, the last value is moved to there. Okay, and well, because as we talked about it before, in a sine graph, the sine graph is continuous, something like this. Okay, now the whole thing moved 1 unit, so it should have this shape there. And let's connect it, it's become something like this. Okay, it looks similar shape, just translated slightly. Okay, so this is your new graph. So your graph will be this graph is your y equals to sine x plus pi on 2 and plus 2. Okay, and the domain is x from 0 to 2 pi. Okay, the whole thing is moved up and moved to the left. Okay, and sorry, the value can be found. The vertical translation value is just there. Okay, the horizontal translation value you have to make whatever in the bracket equals to 0. Okay, that's the main point.